This is exercise 11, graph one full period of f of t equals 4 sine 3t minus pi. You probably notice these are starting to get more complicated. We have more issues going on, and this one is quite a bit more difficult. What we're going to do is work through this one, exploring the situation, and then after we do this example, I'll give you a systematic procedure you can apply to graph these more complicated transformations of sine and cosine. So let's get started thinking about this one. One thing we notice is just notice the input is t. So sometimes we use t for the input variable instead of x. So t is just like x. You could write the whole thing out with x if you wanted. And then I do notice that 4 is in the place of that a variable. And it looks like 3, the coefficient of t, is where our b would be. So I can say a is equal to 4. So the amplitude is equal to 4. B is equal to 3. So the period, which is equal to 2 pi over b, is going to be 2 pi over 3. So that's all matches up with things we've already discussed in here. And what about the horizontal shift, which is one of those transformations we've just started talking about, right? So you might look at that and want to say the horizontal shift is pi to the right. There's an approach that works that way, but we're not taking that approach. We're going to say no. The horizontal shift is not pi. So from the way this is written, this is not our horizontal shift. Okay, and so that's what we got to get used to here. So of course the question is, why not? So let's look at an inequality. So we're going to kind of dig through the details here, but then we're going to try to make things simpler. So what I want to do is look at just one period. Using an inequality, and I guess before I move that up, I want that expression for the function right here. What I'm going to do is in between 0 and 2 pi, I'm going to write that expression inside parentheses, 3t minus pi. And we kind of saw examples where even a more complicated function will go through one period when the expression inside parentheses takes values between 0 and 2 pi. Now what we want to do is we want to isolate t. And so I'm going to add pi to each part. I get pi is less than or equal to 3t is less than or equal to 3 pi. And then I'm going to divide by 3. 3t divided by 3. So I get pi over 3 is less than or equal to t is less than or equal to pi. Okay. Now, this interval represents one period. But wait a minute, we just set up above that the period was 2 pi over 3. So you might say, where's our 2 pi over 3 here? Well, this is like an interval of x values from pi over 3 to pi. This distance is pi minus pi over 3. We got to subtract. And that's like 3 pi over 3 minus pi over 3 is 2 pi over 3. So there's our 2 pi over 3. This is one period. So it's the distance from pi over 3 to pi. And this pi over 3 here at one end is our horizontal shift. And what we're going to do is we're going to end up taking that interval from pi over 3, I'm trying to write, to pi, and we're going to separate that interval into 4 pieces. So we're going to cut it in half and cut it in half again, and we're going to find each one of these values in between, because that's going to help us figure out where to put our high point, our low point, and our zeros. Okay. Now there's another way to see the horizontal shift, because if I were you, I'd say like, I go through all this, and there's the horizontal shift, and eventually we'll have a formula for this also. But another way to see the horizontal shift for this function is, let me just write this out, another way to see horizontal shift is to take the expression in parentheses again, 3t minus pi, and factor out the b value from these two terms. Okay. Now how do you do that? How do you factor out a 3 from pi? There's no way to do that, right? Well, there's a little trick to doing that. You can take that pi and you can multiply it by 3 and divide by 3. Okay, so that's a little bit of a trick. And that allows us to have a 3 that we can factor out in front. So this 3 and that 3 are the 3 we factor out in front. What's left inside parentheses is a pi over 3. Well, if we factor out b, now we see the horizontal shift. Now we see the horizontal shift. Okay. And this is normally called in trig we call this something else. We call this phase shift. So we say here the phase shift is pi over 3 to the right. Okay. We're going to use that. Phase shift just means horizontal shift. Now, what I want to do is I want to break this up into pieces because this video is already kind of long. So we're still going to work with this function. We found the amplitude, the period. We had an inequality way of analyzing it, if you like that approach. You can also factor out the b from the expression 3t minus pi. To find the phase shift will always appear inside the new parentheses. And so to be continued in the next video. We're going to stop this one, and then we're going to put our graph together. We're almost there. We've done all the hard parts of this.